But we can also, in this expression, put in another list. All right, so we can see that it is another list because it's very type manifest, right? It's square bracket. And within that, we want a systematically generated content. All right, and that loop variable has to be different from I, otherwise it'd be super confusing. So for j in range 10, 11, 12, 13, 14, calculate j times I or I times j. Now, in this inner list comprehension here, the j is looping rapidly for a fixed value of I. So when I is 1, it is fixed 1. And then we have j ranging from 10, 11, 12, 13, 14 times 1. So we'll get 10, 11, 12, 13, 14 as a list. Spit it out first, right? And then I, so this part is done. And I will get the next value, which is 2. So when it's 2, there's a list comprehension to be produced with the variable j. And this time around, we have a new range, and 10, 11, 12, 13, 14. But we are going to have 2 times j now. So the I is held constant. So it is like a for I and then for j nested loop, just like that. And we will have 2 times 10 will be 20, 2 times 11, 22, 2 times 12, 2 times 13, 2 times 14, and so on. And then we have 3 times 10, 11, 12, 13, 14. Then 4 times 10, 11, 12, 13. There's no easy way, all right, easier way than this to produce a list of lists of these contents, because you will have to have a for I in range and then for j in range, but you have to create a temporary list and then append onto an outer list. So it will be slightly longer, slightly more involved, and less clear, because over here is clear. We're going to have a list comprehension generating for I range 1, 2, 3, 4, and the outcome is a list comprehension. So, you know, it's very expressive, and if you allow me to say it's super powerful, it is, right? So I hope you are getting used to it. Once you get a hang of it, it is actually quite indispensable. But don't abuse it, because don't try to pretend that all the double nested loops for I for j, you must always convert it into list comprehension. That's not true, because sometimes we loop for control purposes. All right, so if you want to do for control rather than calculation oriented purposes, you want to really just put the for loop as the main controller. That is more expressive, that is more correct, that is more logically sound, and that is more programmatically clear to other programmers and to your future self. All right. Next, we have tuple comprehension. And not surprisingly, it is the same as list, except in a very interesting way. While we are generating the tuple, while the tuple is being produced, right? So values are not fixed yet. It is not considered as expanding the fixed tuple and therefore producing an error. It is okay. It is like I don't know how to put an analogy to it. It is like a tuple that is allowing you to create the contents before freezing it as read only. So it is kind of very interesting in that sense. Let's look at an example to see what's going on. All right. So we have here, let's just run it first. Simply having a manifest type tuple, right? Because tuple is signified or created by having a parenthesis round bracket. And then we just plonk inside a for loop in this for. The body, the single line expression is placed in front of the for, and the rest will be the same for loop. So here we are generating I to the power of 3, I cubes, for I valuing from 1 to 3. So we should get 1, 8, and 27. So while the for is running, right, is looping, and the 1 is being created, and the 8 is being created in the midst of this tuple, Python doesn't consider that as violating the read-only property of tuple. So in an interesting way, while the values are being produced and one by one streaming into the tuple, it is not considered mutating the values of tuple. All right, if you understand what I'm trying to say. So that part is interesting. We can keep on adding values, and then when the for loop is done within the tuple comprehension, then it's frozen. So the whole thing now cannot be changed. If you try to change it, as usual, Python will disallow and raise an error. Now, T is a tuple that is being generated, all right, from tuple comprehension. The difference between list comprehension and tuple comprehension, right, over here, is that when we look at the type of X earlier on was generated by a list comprehension. What is the type of X? It is explicitly list. Very clear. Yeah. But when we say what is the type of T, interestingly, it is not tuple. It is a generator. So there is a little bit of a confusion here because strictly speaking, the bracketing is not having the same behavior as a read-only list. It is having a generator, right? So our earlier joy that as if we have found a secret in Python, momentarily allowing us to have read-only tuples violated. It can be appended onto with a magic for loop inside the tuple with a tuple comprehension setup. It's not true, right? So in a way, this is actually a generator. Python kind of allows that, but gives us a generator, not a tuple, because it is kind of problematic to say that, wait, when you have a for inside a tuple comprehension, the read-only property of tuple is momentarily ignored. And that's dangerous, right? So what happens is Python treats this as a generator, and in general, a generator can have its value being modified in the sense of being created and appended. So how can we get a tuple? Very simple. We just wrap a tuple around it. Okay. So here we just say what is the type of T2, and it's now a proper tuple. So in short, for tuple to have a so-called tuple comprehension, a proper tuple comprehension, so that after the for loop, you actually get a tuple data type. Just do a tuple bracket instead of just single bracket. You do a tuple bracket like this. Interestingly again, this is calling a function tuple, right? This is actually not special tuple comprehension setup or whatnot. This is just calling the function tuple with this value, with this generator value, and that's fine, right? So in a very strange way, this works. So what is the type of T3? A tuple, which is kind of nice. So if you would like to have list comprehension, but the data type is going to end up being a tuple rather than a list, try to do this. This will be efficient. Okay. Try not to generate the list first and then converting it into a tuple. That might be less efficient. But if you are not worrying about efficiency, just do whichever way is more obvious.